Hello viewers, welcome to our channel. I hope you like this channel. Please subscribe this too for further current current information related to the Python and programming language. So today we will talk about again more data types under the Python programming language, suggesting it's a part of Python learning presentation or course. Let's break down the topic in detail to explain what more data type typically covers in Python. So generally we are talking about more data type. Python basically support several built-in data type beyond the basic ones like integer, float, and str, that is known as structure. This slide likely introduce the advanced or compound data types that are essential for real-world programming. So here the main ones typically discussed. Right now we'll move to the next one. Everything is an object. What does it mean? Everything is an object explain a fundamental concept in Python's design philosophy. So we are taking an example. Everything is an object in Python. So Python treats everything as an object, which means every entity in Python, whatever it is a number, string, list, function, or even a class. Class generally is an instance of some class and has associated attributes and methods. So everything means everything that includes the basic data type like integer, int, string, str, float, that is float point. So complex type like list and dictionaries, that is denoted by dict, and user defined function. So classes and even modules. So for example, we are taking an example x is equal to 7. That is x is an object of class int x is equal to hello. Now x is an object of class str. So data type is a property of the object and not of the variable in Python. So Python are just names or references pointing to objects. So the object itself carries the type information, not the variable. So actually we are explaining some kind of slides. X is equal to 7. It just x refers to an object of type int, and x is equal to hello. You are seeing the slide, you are just understanding all those concepts of Python. So hello. Now x refers to an object of type str. So x first refers to an int object, then is reassigned to a structure object. So Python allows the flexibilities because it is dynamically typed. You don't declare the type of a variable explicitly. So when you are talking about object model in Python, so every value in Python is an object. Whatever it is, type 7, that is class int, type hello, that is class structure, and def, passing the value, type f, that is known as class function. So Python internally uses classes to define every object. Even functions and modules are instances of class. Why is this important? Flexibility. Flexibility means variable can point to of different types at runtime. So uniformity, common behavior like str and len, that is known as length. So it can be implemented across all types. So power of OOP. We are talking about Python. So we can say the power of object-oriented programming. It enables Python's object-oriented features like inheritance and polymorphism. So ease of learning, once we are understanding how objects work, so we can work with all types the same way. So we are summarizing this slide whenever we are talking about that everything is an object. So everything is an object, every value, including function and classes. So is an instance of some class. Variable are reference variable and names point to objects. So they don't have fixed type. So dynamic typing variable type can change during program execution. Now we are moving to the next one. This slide entitled number integers. So discuss the concept of integer and long integers in Python. So particularly how they were handled in Python. So this is the actual example of Python integer. We are understanding the integer in Python. In programming, an integer is a whole number without a factorial part. So especially in Python, int was equivalent to a C, and it is known as C long, which had a limited size depending on the platform, usually 32 or 64 bits. So for an example, 132224, and how we can define it. Actually 132224, it's a normal integer. And whenever we are talking about a long integer, as you can see, a long integer, it is used to represent very large integer that could be stored in the fixed size integer. So that is known as unbound integer value. So long integer are arbitrarily large in size, only limited by the machine's memory. So they were denoted with an L suffix. So we are saying L suffix. So 132323 asterisk double asterisk sign 2. So we are getting some kind of values 17509376329 and L. That is L suffix. So actually it returns a particular value, and we are saying we are showing some kind of results in a number too large for a regular int. So Python automatically uses a long. Important point, just note it down. In Python, the actual discussion between int and long is removed. Whenever one integer type, that is known as int, so it behaves like Python's long, automatically growing to accommodate large values. So we can see all the results. We are showing all the results 132323 double asterisk 2, and we are getting some kind of results. So no L suffix is needed or allowed. So why this matters? Features Python. So small numbers int, like big numbers long with L suffix, automatically handled by int. Type discussions int long just int, and understanding how Python handles large number is critical for just we are saying cryptography, scientific computing, financial applications, and big data analytics. So we are summarizing this slide. Integer, whole number small enough to fit in memory like C long. Long integer, arbitrary precision number in Python with L suffix. And Python, another Python series like an unified int type for all integer values regardless of size. So next slide shows the numbering floating point. It explains how Python handles floating point numbers and how to convert between integers and float. So let's go through each point and examples in detail. So what are floating point numbers? Floating point numbers in a number that has a decimal point. So it is a float data type. Float data type. We are saying int x. It converts a number to x to an integer by truncating the decimal part, and it's not rounding. So int 2.0. And whenever we are saying float x, so it converts a number x to a floating point number, that is add 0 if an integer. So float 2, again floating point precisions in Python, we can say 1.23232. So we are getting some results. So this is actually showing a floating point precision issues. So computers use binary fractions to represent floating points, which causes tiny errors in representations. So but Python print 1.23232. So the print functions format the numbers nicely for human readability and hides the extra digits. So the discussion is all about the scientific notations. So scientific notations 1.3E7. So that is known as 13000000.0. So it means 1.3 into 10 to the power 7. That is 13 millions. So Python supports scientific notations using E or small e for large or very small numbers. So we are again summarizing the slide. Operation results, that is 1.23232, and we are getting some kind of results, and floating point precision issues. So generally we are saying the floating point numbers, it converts x to an integer, float x, it converts x to a floating point, and last, the interpreter shows a lot of digits. So in next video we will discuss about number complex. So I hope you like this video. Please subscribe my channel too. Thanks for watching.